All right, so starting the recording, go ahead and share. Any questions you may have may go a couple of different directions. Now, installation for Jupyter Notebook. So let me phrase this a little bit beforehand. Google Colab is a really excellent resource. Doesn't require any installation, runs a lot of the different packages that you may be looking to use. But if you're looking to work with some more extensive processes, you may need to be able to use in a local environment. So there's two ways you can essentially go about your installation. Go ahead and start sharing the screen here. You're essentially either accessing your information from a pip installer. Now, this is something that does need to have been installed previously. So as part of your installation, you do want to eventually consider having that installer set up on your local computer for Python. Now, this is not something we've had a chance to do yet, but you can essentially install different type of package installers or environment installers like pip. This is probably one of the more common tools that you'll be using. Now, if this sounds very confusing, if this whole concept of understanding running commands from the terminal seems to be a little bit overwhelming, that's quite all right. There is a much more user-friendly way to access Anaconda. Or access Jupyter Notebook. You could very well just install an Anaconda distribution. So what this is essentially it's essentially a built environment that you install, download to your local computer, and have running as its own application on your local computer. When you download the material, you'll essentially get asked for a specific little bit of a package itself, and you'll see that it starts to download the package on the left. This part's very straightforward. It's a big file, about 500 megabytes or so. Now, there's one tricky part that I want you to not necessarily click through for those of you who are PC users. So heads up, Anaconda works with Mac and with PC. So both methods are absolutely available to you. So I'll give it a second to download. We pause the recording while we get this going through. But okay, so once you've got that downloaded, I'm going to open up the Conda distributor. And I'm going to try to open this up in a different file. So you get something like this. Essentially, you're going to need to click through these files. So I'm not going to finish clicking through it, but you're going to be asked to go through a README. It's going to talk a little bit about the modified path. There's a license, there's a destination. I agreed to the information. Rather than clicking the install location, that's going to continue. Where is? Okay. So I'm not going to go ahead and click install, but you're just going to want to go ahead and click on the install button for this one. Now, for PC users, so if you're on a MacBook, you can just go ahead and click install, and it should go around and installing for you. So for PC users, Anaconda PC installation, just a moment. There's one section that's going to be a little bit different for you. And this is important. So if you're working off of or if you're interested in eventually working off of a bash or like a command terminal, which generally for implementation and application of certain programs, you may find that necessary. The default is set to register Anaconda as your default Python environment. But in a piece for PC users, you're actually going to want to click on this add Anaconda to my path environment. And when you add that, you'll actually get a very scary warning sign saying like, this is not the recommended way to do that. But you still want to actually go ahead and do that from the very beginning. Because what this allows you to do is to eventually, rather than having to go through a specific software to upload Anaconda, to upload Anaconda or your Jupyter Notebook, you can just type out the terms you're working from your command line. This will open up your notebook environment automatically. So that's one step. We're going to go ahead and I already have it open on my side, so I'm going to leave that going for right now. But for you, so you know, for PC users, if you're ever going to want to work off of a terminal or of a bash, you want to make sure to actually click this top value on as part of the installation. So this one here above, make sure to do that. Once you've done that, it'll take about 10-15 minutes to install. And then typically, if you have it, like whichever way you install, it's going to essentially be a set of different, like it'll install an application on your local computer. You do not need to install anything else. You don't need the added idle information. You don't really need any of that. Because at this point, if you're on a PC, am I sharing my screen? Yes, I am. Cool. That was going to be annoying. If you're working on a local computer, and my applications, you should have Anaconda Navigator installed on your local computer, or in your applications, or in your search. If you're on a PC, it's doing a search for Anaconda Navigator. It should pop up on your start menu as well. Anaconda Navigator, again, is a distribution of different programs that runs files in your on your local environment. You'll have, once you double click to open it up, it'll return a kind of little green circle. You know, it's a snake to open up the environment. It's on one of my other screens, but I'm giving it a second to open up. Here we go. So it should look like this. This returns a number of different files and they're in a different set of versions, including Jupyter Lab, Jupyter Notebook, PyCharm, VS Codes, things along those lines. It's taking a second to load on my side. It is now loaded. It's running a little bit slow on my side today. There we go. What is going on? Oh, interesting. Let me restart it on my computer because it seems to be running a little bit tricky there. I'll be right back. All right, so the problem is I probably need to update this. So I'm gonna have it update afterwards, because I do need an update of Jupyter Notebook and Python here. So here are the different files you can open. We're working off of Jupyter Notebook, so you can click on this. You'll see that it opens up a command line on your terminal. If you're on a PC, it'll do the same thing. But what this does is it takes you to your base location in your drive. Essentially, this is the very top of your user file, and all of your folders presumably located within them. And that means you can essentially navigate to different locations within your library. So what does that mean? Say, for example, I wanted to create a Jupyter Notebook file or work on a specific document in a folder. I could essentially do that inside my documents folder. And this environment allows me for a little bit of creative space because now I can create files on my local computer. So you'll be having an extension of your files. It'll tell you what files, what notebooks or what text files are being run. Think you also have clusters. There's a few things here that are extra that you probably don't have, so don't worry about it. So particularly these three things are added installs. But once you're inside of a notebook, you're essentially able to create a fresh new notebook essentially off of your environment. So for example, if I wanted to create a brand new notebook, I can be a folder, a terminal. Here's my new file that I'm going to create. Creates a brand new untitled folder at the very bottom. I'm going to rename it by clicking on the checkbox, going over to rename, and opening up my folder for Jupyter. So there's my folder for Jupyter. Now there it is located under the Django profile files. Let me go ahead and show you where it appears on my desktop computer. Here's the documents. There's my folder for Jupyter, all on my local computer. So when I click into it, I can create a brand new Python 3 notebook. Now, depending on what software, what languages you've got installed on your local computer, you will see some other languages present there as well. So if you were working with R, SQL, or other types of environments, you may end up having different languages to consider. But then this part of the notebook is going to look fairly familiar. You have access to your shortcuts, the different keyboard shortcuts, very similar to what you would have in Google Colab. Essentially, you can create or modify your own shortcuts. You can essentially add some additional widgets and other environments. You can take a look at some of the guides that are present for the access to the documentation files inside pandas. And from there, we can essentially begin to see the different files that you may find yourself working with. Give me 5 seconds here. All right. So from here, you've got your first line of code. And essentially, from this point forward, it's essentially the same thing over and over again. You can essentially create your packages. Some of these packages come installed as part of Jupyter Notebook's Python environment. You'll see a few files with pandas, NumPy, all of these things get ready to go. Now, what I like about working with a local Jupyter Notebook is that the autocomplete is a little bit more intuitive. I can just click the tab button right next to my Q on my keyboard to autofill or prompt what my next locations are going to be. So in this case, I remember I'm using PyPlot. I can tab it out as PLT. So there's a little bit less delay depending on your internet connection, and there's a certain amount of intuitiveness for your autocomplete purposes. Once you have your different files included, you can now begin to navigate the different notebooks as part, like you can essentially treat your notebook as a local computer. So you can run all of the same parameters and all of the same functions that you did in Python. So the same thing that works in Python, like object list. This is a list of names, whatever you want it to be, 1, 2, 12, 23. So they work exactly the same way. There's a slight difference here, though, and essentially one of the more specific components of working with Jupyter Notebook. When it comes to actually accessing a CSV file, it's a little bit different. For one, just because you have a local notebook on your computer doesn't mean you can double click to open it. In my case, it did because I've got this VS Code running as a default value. Bad VS Code, ruining my example. But generally speaking, sometimes you'll get, most of the time you'll get an error with a specific notebook. But because you're working in a local environment, say you need access to a CSV file. Well, up till now, a lot of the work we've been doing is kind of connecting to a URL for our data sets. That part still works the same way. So if I were to look at a URL for one of my class lessons, let's just take it, for example, from that intro to Python class. Where is that? The wrong lesson. Never mind. EDA. URL. Yeah, so if it's as a URL, I'm going to take that URL, take it back to the notebook that I'm working on. Like, it'll still work the same way. So that's your URL. You can PD read CSV or a URL file. That part's the same, right? This is what we were used to doing in Google Colab. The difference is, as we did today in class, where we uploaded a file to our Google Drive environment, it's a little bit different in Jupyter Notebook. Because in this case, you actually need to make sure that your file is located somewhere, like somewhere specific on your computer. So your CSV file has to be located somewhere on your local computer. What do I mean by local computer? If I type out ls, what this will do is it'll showcase all of the files that I currently have inside that folder or inside the directory where I'm currently located. I wanted to navigate outside of that directory, I need to change my directory and double click to highlight that I'm trying to go into the documents folder, essentially navigate one direction up. And as you can see, when I do that, I've essentially listed all the current directory that I am in. PWD is a term that stands for print working directory. What this refers to is that currently my environment, or the code that I'm running, is operating from the documents folder. With me so far? Maybe. But what I've done is essentially gone from where I created this folder in this location. And sorry, I created the folder in this location, and I've navigated up one level, and now I'm currently here. Chelsea's status. Yeah, let's use that. Okay. So now that I'm in this area of my information, I actually need to click through the rest. The way I can do that is because I ran this ls, I know what folders are currently located. I'm going to go ahead and navigate over to Chelsea's data sets here by reading in the files that are going to be located in there. So I'm going to cd into Chelsea data sets. I'm going to double tab to remind myself what the files are called. I don't actually remember, so I'm just going to run that so that it changes my directory to where I need to be. It's called data sets. So I'm going to change my directory into data sets. Cool. So that means I'm currently inside this folder. And I can navigate to see the files in this folder. I know some of these values are in here. So these data sets are all currently living on my personal computer. As a matter of fact, you might recognize quite a few of this. So let me go ahead and call on these objects to read them in as PD read CSV. Let's do the mosquito CSV here. Note, I can autocomplete. And what I'm doing is reading in the directory as long as, while recognizing that my notebook is currently located inside that same directory. But note that I had to navigate there. This whole process was essentially me, oh, where's my notebook saved? Where do I need to go to? That's essentially the process that we're seeing happening there. Now, what happens, however, if my files are located somewhere else? So I'm going to go ahead and navigate back up, for starters, just for this example, into what's the name of that file? It is called folder for Jupyter, cd folder for Jupyter. So I just want to navigate there so that we have the starting point that I am currently inside the folder for Jupyter notebook. I want to access a data set that is currently inside my downloads folder. Let's call this is the one I was trying to open up earlier. So let's call that one MIT alum, whatever. So I'm going to read that in directly without actually having to navigate it. I need to go up one level. And note that as I tab my way up, I'm my dropdown is essentially prompting where my locations might be or what I might want to add next. So here's some code grade materials. There's my downloads folder. What's inside the downloads folder? This is me tapping on my values just to look through my objects. There is the CSV file that I was looking for. I'm going to save this to a data frame. Whatever pops out, run this on its own. This is the data set we were working with earlier. Which is pretty cool, perhaps. But what does this help me do? Well, now we're at the stage where we can essentially make changes to data sets and data frames and then actually save some of those changes in an environment. Not only save it there, but we can also essentially convert those into other values. So for example, I find the toCSV method in Pandas super useful, but it does require me to actually create those files inside this local computer. In Google Colab, it would create the files, but it would still be saved on your drive. You have to download it and make sure you don't actually erase that file. So let me go ahead and just make a slight change to this data frame. Let's go ahead and take a link. Let's string upper all of it. Yeah. All right. Let's make Romeo and Jupiter, and let's make Romeo and Juliet a little bit more intense. It's all capitalized. So that's my new data frame. This is going to be called df.upper. Keep it simple. So all I've done, I've gone through all of the values in the data set. This saves my values to a string. Let me actually make sure that's still a data frame. So I'm going to save this as a data frame called df.upper. Note that what I'm doing is I'm actually using tab to autocomplete all of my consistent variables. This df.upper will now be my intense data frame. What I like about this method is that df.upper, because it's still a data frame object, I can now save this to a couple of different objects. So for example, I can have this be a CSV file. And the thing about the to CSV format is that you actually need to name your path or name the file itself. You can change the path perhaps if you wanted to, but I'm just going to call this uppercase Romeo, uppercase RNJ. And then I'm going to add the extension CSV. Doesn't look like it does much. But if I go to wherever it is I saved this file, where did I save this? This was located in some downloads. No, that's because my file is actually inside folders for Jupyter. Ta-da, there it is. Is something like this useful? Well, because even if I don't do to CSV, well, you can essentially begin to implement files of this format. What do I need to do? Do I need to specify? Yeah. Excel. No, is it not to Excel? What is the one for the one to Excel? What do I need for this? Excel writer. Oh yeah, that's right. So it's .x xlsx. Is that right? I think. Then we'll call this uppercase G. No engine file type. Let me remember what it was to do this. To Excel. What are the formats for it? Oh, go ahead. XLXX sheet name X sheet name 1. Is that how it needs to work? Let's see if that's how that works. XLSX, is that what it is? XLSX. Let's try that. RJ. Syntax error is happening. There we are. Okay, that took forever, but there we go. So you take your to Excel, that's my RJ. And now if I want, in this case, it'll open up in Pages. Second, because Pages runs super slow, which is why I never use it. But there's your data set as an Excel file if you ever need it. Jupyter Notebook is a little bit fairly well structured. You can title your page here. Now, again, this is your local environment, so you don't have to worry about your files being on the cloud. You need to make sure to close your values. The other differences is that, you know, some of these versions are a little bit different, but like they're all essentially the same thing. You can close your file out. I'm going to go back to the lessons itself format. So what are the ones that are running? Yep, you can actually keep track of what files are running in any given environment. This is the one that I've got running. Those terminals are running. Now, the thing you need to know is that this is an engine. So making sure not to click this, which will turn off the processes that you're running with your notebook. It's one of those things that you want to typically be aware of. I'm going to go ahead and close those up. Quit Anaconda, and that is it. So now you can do work. Essentially, if you're interested in saving yourself some effort with the files for Sprint Challenge, for example, this is just a little bit of an easier step-by-step process. And that's it. Any questions?
I guess just because I'm interested, we want to rip off Jupyter Notebook.
Oh, I'm so glad you asked that. Yes, actually, kind of exactly that.
Yeah.
So yeah, so here's the no. Thank you for asking that question. I always forget. So my understanding is that Jupyter Notebook was here first. Google Colab essentially then created that environment for its own, so that you could actually have something running in the cloud, and it actually works fairly effectively. Like, the fact that you can kind of install whatever package you want to run. Google Colab, like, it's actually fairly strong. It's actually a very strong environment. Like, this whole portion of it, the fact that you can add a number of extensions, the fact that it's got a pretty good set of resources available for you to just get started with it is actually pretty cool. Like, I actually really like the fact that they've got some text classification models ready to go for you and learn within this environment. Like, if you tell me that my future is working in Google Colab all the time, I have no complaints about that.
Honey, I can't listen to you right now. I'm listening to my teacher. I'm sorry.
And here's the other thing. Before, I think around the same time, let me see if this is still running, because I know I've taught a few classes on Microsoft Azure Notebook. Let me see if they're still up. Yeah, so let's see. Visual Studio, interesting. Okay, so they switched gears here. Started with Azure Microsoft Notebooks. Nope, okay. Yeah, now they still have notebooks. So they essentially integrated their own Jupyter Notebooks into their Azure products. Azure is essentially Microsoft's version of their cloud. So again, you've got Google Cloud, you've got Azure, part of like the cloud systems. They all have notebooks as part of their environment. So I don't want to sign into Microsoft because it's fine.
Which one of those services is the like most, I guess, fluent to like start out with when it comes to like Azure and
Google Colab?
Oh yeah, right.
Yeah.
But like when it comes, I mean, is Azure in a sense what Google Colab is for Microsoft?
Yep.
Oh, okay.
Yeah. Yeah, it's like Microsoft Teams, and it's like how Microsoft. I cannot be recorded for this. Hang on. So the big companies, Microsoft has a cloud environment, Amazon has a cloud environment, and AWS. So these three, and Microsoft just calls this cloud environment Azure. So Azure and AWS again also work in a similar method. What they're essentially selling you is a cloud platform where you can run different processes. If you want to store data, if you want to store big data in a cloud environment, you're doing it through Microsoft's Azure environment, Amazon's AWS, or Google's cloud. So this is referred to Google Cloud Platform. You'll notice that these are all essentially running the same set, like they're all essentially offering the same services, where rather than having to code or store your millions and millions of rows of data on your local computer, you can essentially pay and have it stored on a cloud and run some of those processes through that interface. So this is a big component of how you're essentially running, how essentially many of these major companies are essentially running their different processes.
Just start promoting Jupyter Notebooks. I feel like you could So it's just a cloud service. Okay, that makes more sense when they talk about it.
Yeah.
Because I'm like, what is like the magic behind all this?
That is the
Okay.
magic. Just they're all the same
Yeah.
thing. They've just put a different. They've got a different theme on it.
Did you guys start a virtual environment when you? I missed the beginning of.
No, we didn't. I just installed it and downloaded it. To summarize it, just go to if you're working on a PC.
Yeah.
Okay, if you've ever installed an environment before, or if you're comfortable with pip installation, just do pip install notebook.
Oh.
Yeah.
Okay. So when it comes to virtual environments, is there like some people do it like every time, like in tutorials, but like it doesn't seem to make sense to do it every time.
It's okay. So the general consensus is that when you create an environment in your local computer, it's because you're incorporating some packages that may potentially make changes to other parts of your, essentially other parts of your computer. So for example, much as how I've talked about, you don't install pandas and scipy, or you don't install all parts of sklearn because there are packages that may conflict with each other within the use of sklearn. Like sometimes certain packages or certain programs that you download may affect your computer's operation, your local computer's operation. So an environment allows you to kind of create a stable environment that's copied from your local computer, but any package that you install or download is limited to that environment. So frankly, I have a base environment to which I install my general packages like Python, pandas, like the basic ones. And then if I'm doing things that I know are like when I start to do things that are affecting the OS, like if I'm running Pygame, for example, which automatically loads up Windows on your local computer. Pygame is just a fun little way to practice making games with Python. But it will, like I would do that in an environment. The same thing goes for TensorFlow. TensorFlow, because some of the operations can be very excessive, like you're running a lot of different processes while you're evaluating a specific model. You can easily free up, like you can, rather than have a situation where you freeze up your entire computer, you run that environment, you run TensorFlow in a specific environment. That way you can still run other processes on your computer while you're still working locally. This is besides the point if you work in a cloud environment, of course.
Right.
Yeah.
Okay.
The other thing that you might use different environments for is like, you see how every so often Google Colab pops different warnings or deprecation warnings. A lot of that has to do with the fact, yeah, exactly. It has to do with which Python version you're choosing to work with.
Okay.
Mm-hmm.
Yeah, because in the beginning, sorry.
No, go ahead.
When I first found virtual environments, I just made one over and over to get used to it. And I look in my Anaconda, you can look at your environments you have created. Mm-hmm. It was just 300. I had to go through, clear them all.
Yeah, you would want to minimize. You don't need 300 environments, but yeah. This becomes applicable for everyone else on Unit 3, I believe. So you'll have plenty of chances to work with your local environment. There's also ways you can automate the environment that you choose to work with, and again, it depends depending on which type of environment you're working with. It can get tricky. But man, I've been guilty of just installing some really weird packages on my base just because I'm the heck with it. Now, a brief warning as you get stronger at so here's the thing. I teach an Anaconda distribution right now. People who've been doing this for years and years and years will tell you that the Anaconda distribution does create a number of environmental conflicts with other packages. As far as installing certain packages effectively, even updating Python can be a little bit of a pain in the butt when you just work off of Anaconda distributor. What does that mean? 2 or 3 years from now, when you're buying a new laptop or a new computer, or you've got the job, or not 2 to 3 years from now, but when you get a job that sends you your own computer, double check, like look up how to install Python and Jupyter Notebook or whatever environment that you're choosing to use directly onto your computer without the Anaconda distribution. Because if you're essentially if you're a developer, a big component of how Conda can affect your environments will essentially can get a little bit tricky, simply because Conda sometimes doesn't work super well with other environments. It's not something for you to worry about until like down the road. What I like about Anaconda distributor is that it's easy to go and it's set up, it's user-friendly, but it does sometimes play unfairly with other environments. So like, for example, I have to create a new environment if I want to use the updated version of Python. Otherwise, I think it's defaulting to me to 3.7. But for right now, what some of the best tools you can use is essentially just longbones.core for right now, or for example, longbones or Seaborn.pairplot longbones. Those two are going to be your go-to methods at this point to understand which features are the most likely helpful methods you can use. Now, I'm saying this for right now because the other methods that include essentially give us a look at specific in the interaction, like have us looking at the interactions between those individual features. In other words, if we're trying to predict time, what those features are going to do is they're going to look at the interrelationship of depth and age. And if it sees that there's enough of a correlation with those two features, it'll incorporate that interaction into your model. So there are automated processes that essentially will return those values for you. But for right now, or at this stage in the game, it's just a matter of knowing what an independent feature or how an independent feature affects your target values.
Okay, thank you.
Hey, Julian, my computer crashed yesterday, like in the beginning of lecture.
Oh, no.
By the time it rebooted, I forgot to do attendance as well.
Awesome.
I didn't know that. I've got like a little red circle and a negative sign making you go crazy.
Yeah, no, it's all right. So I will share my screen. All right. So this was yesterday. Stephen, I blanked out on your name there for a second. There you go. Got you for linear algebra. That was yesterday?
Multi-regression.
Yeah, there we go. Status sucked. All right, cool.
Cool, thank you.
Other questions?
No other questions from me. You all have a good day. Thank
All
you.
right. Talk to you soon.
See you guys.
Yeah.
I wasn't sure if it looked frozen.